Thank you, ladies and gentlemen. As I said it, we are all involved in the success of this conference. All of you know that technology is a great enabler. It has helped improve productivity and also compliance to food safety standards. How can technology help cashew sector to improve competitiveness and compliance? To discuss this topic, let's welcome, ladies and gentlemen, Mr. Shakti Pal, Caro Nut, and experts. Mr. Shakti Pal will be the moderator of the coming session, and I will let him introduce himself, the speakers. Ladies and gentlemen, Mr. Shakti Pal.
We need more chairs. Hello, good afternoon. So now we are starting a very innovative session. We talk a lot about fears and prices. Everyone is motivated and demotivated. So let me bring some energy to talk about solutions, increasing a bit of our competitiveness, find a solution, So, is it working? So this session is going to have 6 participants, and we will talk about different solutions, how we can use cashew byproduct, which is cashew shell. We are working on this from last 2-3 years. I think TechnoServe took this lead on it, and now there is a solution, there is a business case, and we know what we are going to do from now. It's a commercial product in the market. Then we will talk about a bit of new heights of mechanization and adequate mix of automation. And the Burma kernel, which is an emerging trend. It's happening very well. 35,000 metric ton of Burma kernel exported to Vietnam last year. Quite a big reality. Solar energy. Can we imagine 85% of reduction in the electricity bill by having solar panels? A new approach on post-harvest handlings, how we can adopt new way of packing things and post-harvest handlings, and new mantras on RCN production and quality. This picture I took in Vietnam, so you can understand this year Vietnam production is really good. So let me introduce our speakers. Let me invite first Mr. Sundaran Damodaran. He is the Vice President of Thermodyne Technologies, which is a champion in thermal energy and, sorry, can I have this one? That's much better. Sorry, yeah. That's better. So Mr. Damodaran, actually, he's the Vice President of Thermodynamics Technologies. He's a champion in thermal energy and thermal energy conservation. He's a mechanical engineer, over 20 years of experience in procurement, marketing, manufacturing, and dealing with energy solutions. Mr. Damodaran served many big enterprises, and he's based in US. Our next speaker is Mr. Dang Van Thuyen. He's from Mekong Industries, a champion in technologies. They actually install a lot of factories here. We will talk about Burma kernel, Mr. Stephen. He's from Longsan, almost 15 years in processing and dealing with raw nuts. We saw him quite frequently. He just not a champion in processing, but also on other issues, new trends. There's another speaker. He is not going to make it, Mr. Kalbhavi. He was supposed to be here, but he's not coming. He's going to talk about, his panel was on the solar energy. I will take that session. Then Mr. Stefano Massari, I think we all know him. They are the people who started technologies late 50 years, 60 years back. And now they are back again with the new innovations on packing solutions and post-harvest handlings. And Mr. Peter Massavi. Mr. Peter Massavi, give him a big applause. Mr. Peter Massavi, he don't need any introduction, we all know him. I was passing from north of Cote d'Ivoire, and I stopped under a tree, and the tree was asking me, how is Mr. Peter Massavi? Every tree in Africa knows him personally. So that's Mr. Peter Massavi. I will not take much time. There's another speaker, actually, and he also not going to make it. Mr. Jeevan, actually, he was supposed to present something on the grading solutions, that how in one pass we can have different grades, but we can go and talk to them on stall number 29. They are not around. So without taking much time, let me introduce our first speaker, Mr. Damodar. Stage is yours.
Good afternoon, ladies and gentlemen. My name is Shankar with the Moderator Technologies, and I want to thank you for your time and attention and for this opportunity given to us. Today, we're going to talk about generating renewable power as a byproduct from cashew processing. So we'll review the current practices, and we'll review the opportunities, and we'll evaluate them, and also review a case study. As you can see, cashew fruit, we have cashew nut, which we all love to eat, and then cashew nut shell is a byproduct. Cashew nut shell is sometimes further processed to extract the CNSL, the cashew nut shell liquid, and right there at the very bottom is what we are interested in today, and to see what opportunities we can make out of that. So for the purpose of easy explanation and communication, we are looking at all cashew processing plants, like small, medium, and large. And in this slide, we are looking at a small plant and a large plant. A small plant may mean 20 tons or 40 tons, but just for the sake of simplicity, we will just call it small and large. As you can see, DOC, which is de-oiled cake, is the final waste product of cashew processing facility. For a small processing plant, we can provide a solution by generating renewable energy through by setting up a power plant, and the advantages are you can save your cashew waste disposal costs, and also take care of your in-house power requirements for your processing plant. In a large plant, if we have the capability to export power, we have the same advantages of cost savings, and at the same time, we can create an additional revenue stream by selling power to the grid. So a little bit about the DOC, de-oiled cake. It is actually an excellent fuel. As you can see, it has a good calorific value, 4,600 to 5,000 kilocalories per kilogram. And in some cases, to put this in context, it is a little bit better than some cheap coals. There are people who fire coal that has lower calorific value than the de-oiled cake. And if we want to burn one step before that, which is the shell itself, you have much better calorific value because the CNSL is still in the shell. The other factors that make it a very good fuel are the fact that it has low sulfur, it's less than 0.1%, and also it has very low ash content, which means that if you put 100 kilograms of fuel to burn in the boiler, on the other end you will have 2 kilograms of ash, which is not much. And then also low moisture makes it an excellent fuel. A little deeper analysis, it has high volatiles. I want to draw your attention to that. And again, like I mentioned in the previous screen, low moisture, low ash, and high carbon. The fact that chlorine is not even there also makes it a very good fuel. So everybody's probably interested in why do we need to do this? And we are going to consider that question in the next couple of slides. We're considering 3 size plans. Case 1, small, case 2, medium, and in this slide we've added another slide, another category, case 3, which is an actual plant that we have installed. So we are considering 40 tons per hour of raw cashew nut. So we're estimating that about half of it comes out as shell. So in different places, depending on where the cashew is grown, I think the percentage may vary. So we are considering 20 tons per day of fuel. That will generate, if we generate steam at that parameter, 45 kilograms pressure and 445 degrees Celsius steam, we can generate 6 tons per hour of steam and generate 0.9 megawatts of power. Now, just to put that in context, 1 megawatt is 1,000 kilowatts, and that approximately translates to 1,000 homes getting electricity. Especially in this part of the world, when we were trying to research on the cost of power, we were told that it is about 16 cents a kilowatt hour, which is very high, which makes this very lucrative as well in this part of the world. First, we couldn't believe it, so we did payback calculations based on 2 costs. One is 16 cents per kilowatt hour, and another one at 10 cents per kilowatt hour. And as you can see here, I'd like to draw your attention to this. It's 2.3 years and 3.8 years of payback. This is very simple, straight payback calculations based on simply avoiding the cost of your processing plant electricity requirements. So we have estimated based on working in the industry with some specialists that your in-house power requirement, as you can see in the 4th row, is 0.7 megawatts, which is 700 kilowatts, and translating the simple cost of capital against your cost of electricity that you are currently buying from the grid, we can we can pay off for that plant in 2.3 years at 16 cents a kilowatt hour, which I think is excellent proposition. Now, there is also an opportunity to sell the surplus power to the grid or have a social impact and electrify homes in the region. As I said, 1 megawatt power will power 1,000 homes. So as you can see, even for a 40 tons per day plant, there is substantial amount of electricity that you can generate in surplus to what you consume in your processing plant. So there is a lot of numbers in there. I think this presentation is available for review, and you can stop by and we can discuss every case on an individual case-by-case basis. Next, I would like to focus on one installation that we have made. The plant is running for about 10 years now. They are actually in the southern part of India, and that is a picture of the plant, and that is a general arrangement drawing. So when I mentioned that cashew nut de-oiled cake is an excellent fuel, there is no perfect fuel. All fuels have some issues, and some of the issues that are associated with the cashew shell is the fact that it has high caustic content, which means alkali metals, which means like elements like sodium and potassium. So this actually presents some challenges, and they are, of course, mitigatable challenges. And some of the features of this boiler that helps us mitigate these issues and take advantage of this fuel for generating power are the fact that it has a tall furnace, which means we control the furnace outlet gas temperature and prevent fouling, which is caused by these caustic elements, alkali metals. And also, along with that, we have extended water wall sections, and probably too much detail for this forum. Bottom line is we have done it, and we know how to do it. We would like to replicate that solution more. So this unit is in operation, like I said, for 10 years, and primarily was designed to fire de-oiled cake, and then it went on to evolve, and they also fire shell, unprocessed, without extracting the CNSL. And then subsequently, selling of electricity became such a crucial stream of revenue that they are now firing other biomass fuels to generate electricity even when cashew production is low. So even in an off-season period when there is not that much cashew nut coming in for processing, raw cashew nut, they use other biomass fuels like wood chips and what we call as juliflora, which is like a wild bush in India. And they are fired to generate electricity, and strategically, this is a crucial stream of revenue for this company. Those are some of the boiler parameters. And so a couple of factors that are crucial for a good boiler design is understanding the characteristics of the fuel, understanding the characteristics of the ash, and then the boiler itself, which is heat transfer surfaces. So the reason I'm showing this is that when we started getting into the cashew nut-fired boiler systems, we had to obviously understand how the fuel flows, what are the physical characteristics, density, how does it pile, ignitability, and so many other factors. Now, this is in our factory, this is our fuel flow test system. The next slide, I will show you the testing in action. Yes. So as you can see, different fuels flow differently, they handle differently. So we have to have them land on the grate in a certain way for efficient combustion. Anybody can make a boiler, but to make a boiler that runs day after day after day continuously, and you simply just forget about it, that is where the technology is. And these types of studies enables us to state confidently that we have done this, we know how to do this, and we can be of help to others in the industry. So what I'd like to do is I would like to urge you to think about a few things. This way, you can generate green electricity, renewable electricity with zero carbon footprint, and create a new stream of revenue. Selling electricity is very lucrative. And if you cannot sell electricity in wherever your plant is, you can at least generate electricity and be energy independent. With that, I would urge you to change the paradigm in this industry and take a step forward towards energy independence. Thank you once again for the opportunity.
Thank you. Thank you very much, Mr. Damodaran. I think we will take questions later because we have quite a lot of speakers here. Mr. Stephen, stage is yours. We have 10 minutes. Now, Mr. Dang. Yes, yes.
Good afternoon, ladies and gentlemen. We are Mekong from Vietnam. We are making the cashew nut machine. Today we come here to introduce some for our machine. We are in the researching and manufacture environment for the science technology in Vietnam. We are the manufacturing the machine equipment for the rye, for the cashew nut and beaver. We supply the turnkey or the single machine depend the requirement of the customer. For the cashew, we are supply for the raw cashew processing plant, for the sand processing land, for the kernel processing land. For cashew able juice for processing. Today I introduce with everybody here with the automatic cashew processing plant. So some 2 years ago, we begin to improve the cashew processing to the increase the automation in the processing. We supply from the with the capacity from 1 ton to 100 ton. We with the 1 ton for 5 ton yield for the family and the small company for the 5 to 100 ton to the stars minimum to the big company. The new factory we have installing in India. The factory the 50 ton with the automatic from the cleaning to the gardening and cooking and cooling. After automatic to the send to the shelling. Shelling after finish shelling, we gardening and to the put on the rack to the filling tray to the drying. Here in processing, we separating in process. For in the first processing, cleaning, calibration. So we design in the cleaning to the with the simple and to the clear the stone and dirt in the processing. Have to the minimize the broken of the selling machine in process. For the sorting side, we increase the sorting size to 12 meters to the with the diameter with the 0.6 in with the thickness for with the correction in the size of the raw cashew nut to the minimize broken in process. Here in the some picture. It's in the steaming continuous, and now we development to the technology for the one the continuous static steaming and second rotating the steaming technology. With the for the cooling, we make the continuous and the cooling system for the reduce the cooling time, labor saving in limit the broken in processing. On On process is controlled by the butterfly farm magnetic and a conveyor system to easy for maintenance and operation. For the selling. And now we are on the cashew from the cooker automatic to the go to in the cashew cell by the conveyor, by air conveyor. For the selling system, we are development the automatic cashew selling with the 10 blam. With the senior broken about mean the 10% with the IB and less than 5 and CD less than uncut in 5 for the easy for entry capacity in the coping. And now we are development scoping. We entry to the vibration receiving for machine with the 4 the air gather and 2 gather. In process, have to the processing in after the cutting and separating in the uncut, uncooked, and cashew broken to minimize the labor in process. It is our process. So you can see in one the layout for selling line. We in one selling line, we in about the 5 machine with the 4 sieving and ruler. In our machine had automatic cutting. We separating one machine in 1 sieving and 1 air luer for the processing for the uncut. Have to minimize the oil contact in the nut and can separating on the cell and nut for the minimize the level in process. Here in the humidify, and now we still use 2 technology and a dryer and humidify with the vapor fan. In the dryer, we use with the room dryer for the with the codifier position opposite the fan 2 sides with have to the circulation air in the chamber have for the unbin cashew had a uniform in the after dryer, easy for billing. And billing, now we had 2 kind, 1 kind for 2 heat and 4 heat, depend the capacity, depend we can make more the linking more machine to one system and can link with direct with the colo sorter to the minimize the labor in processing. In the guarding, and now we development 2 kind of guarding, 1 the whole nut guarding. We use the principle with the ruler guarding to the separating side. With this machine, one time can sorting about 3 sides. With the broken sorting, we use the vibration in the sieving with the diameter of the net to separating the broken in process. In packing, and now in we development in vacuum packing with the block with the 10 kilo to 20 kilo. Together we had carton book packing and thing packing. Okay. Thank you. I had introduced for our machine. Thank you. Okay.
Thank you very much, Mr. Dong. Mr. Stephen will talk about Borma kernels. The stage is yours, sir.
Okay, good afternoon, everybody. So I'm here. Okay, I'm here to talking about the Burma cashew. I know, Africa country, they want to have the cashew industry in hand. Many countries same, right? So, but if you want to have the food industry in hand in short time, it's not possible and very difficult to get it. So today I'm here to show the general picture. It is a short way for African country to have the industry in hand. The case is the Burma kernel. In 2019, we witnessed the strong rise of the cashew industry of African countries, especially led by Cote d'Ivoire. The ingredients for this strong rise is the increasing number of the factories located in Africa, and the volume of cashew kernel export from Africa country to the world, including Vietnam. I can show some picture of the factory in Africa. Very beautiful, no? However, the processing industry in African countries still face many difficulties due to the limitation in the technology, experience, and the human resource. They difficult contribute to industry a new type of the semi-finished products, that is the Burma kernel, or the kernel with husk. And with this cashew business experience, Vietnam has quickly become a customer, the largest market of Africa, especially in Ivory Coast, for this Burma kernel. We can see the kernel import to Vietnam in 2019. 2 tons is around 30,000 tons of kernel. If you convert to ASEAN, it's around 130 or 40,000 tons of ASEAN. Everyone in Vietnam export around 2,500 tons kernel, mostly is the Burma kernel, for many countries, especially for Africa. The trade of Burma kernel brings many benefits to both of Africa and Vietnam. So what benefits for Vietnam? Regarding the environment, Vietnam is the country with very small land, limited land area, and high population densities. Almost the factory are near the city, town with many people living. So the selling will adversely affect the air, soil, water of the residents nearby. So important Burma kernel will have Vietnam to sell her environment treatment cost and land resource. For the construction, building the factory only from the step of building to finish the products is easier, lower than construction cost. We do not need the large area, so it will be easier to build in rural area, very far from the town, from the city, and create more jobs for people in those areas. Shipping costs reduce 70% of shipping costs from Africa to Vietnam compared to import raw seeds, because we don't need to bring the shell. Reduce reliance on import of raw cashew nuts, which have recently led by speculation of raw cashew nuts with forced factory to buy at high price, leading to the unprofitable processing. Have deep and effective division of labor between African country, production country, and Vietnam cashew processing country.
having both side benefits. So what benefit for Africa is very important. Take advantage of vast land resource. Africa they have a very big land. Big human resource. That's very important in low investment capital for factory. If you invest only until the Poma kernel, the capital to invest is around, the value is around 60%. Compared with you invest for the food factory, food line factory, until the final product. Simple technology is easier because after peeling it's very difficult to finish the kernel. Quick capital rotation. Very easy, you can cut, take the fresh kernel, dry, package, ship. That money very fast. Unnecessary high skilled worker is the main problem in Africa because the labor is very difficult for them to remove the skin and writing. Easy getting market for the on grade. If you processing until the end of products, you can sell the white horn kernel. This is low price. Sportic, nobody buy. But if you sell Proma, you can sell on grade, nobody check. Process on country production very fast. It's the best way because everybody can invest. Very easy and very low capital. So it's also the processing time is very short, so easy for some country to maybe can process on the production. One by one step, learn the technology from Vietnam and avoid the mistake. Because we got many mistake from the history. We have many experience for history. So right now you don't need to take the mistake. So the cashew supply chain will be distributed around the world and follow. In Africa, we can do steam, shelling, heating, and packing. The rest, Vietnam will take care of this. Peeling, writing, pasteurization, packing, and ship. Okay, thank you very much, sir.
Thank you very much. Thank you, Stephen. As the next presentation, the presenter is not around, I will try to actually give you a little brief in 5 minutes because that is an important presentation. We are talking about solar energy. In Africa, we have two things. We have too much of sun and we have high cost of energy. For example, a factory which have 50 metric ton a day spend approximately $500,000 on electricity. And how we can use this much of sun which we have and convert that into energy and save 85% of the cost. So that's why I would like to take this next 5 minutes. Okay, this is a real experience from one of the processor in India who actually installed solar panels on the top of the roof and find that was really a big thing for him. He reduced his cost by 85% on energy side. So renewable energy, there are so many ways we can actually get it, but I'm talking here only about solar, not any other means at the moment. Why solar? There are two things. One thing is the technical part, another thing is the motivational part. In India, it is very motivational because there are a lot of support from the government to improve the renewable energy or add to it. For example, if you want to actually install solar energy, there is a subsidy from the government side. What I'm saying here, the African government can also think a lot about it. We are not competitive. This is also one way to bring this competitiveness at processing level. So we say 33% subsidy or maximum of amount. And it has significant cost benefits. And payback period is under 4 years. Okay, let's talk about Kalbhavi Cashews. So this is rooftop solar panels, and we need approximately 8 meters square to have 1 kilowatt energy. That means if you want to install 300 kilowatts, which is approximately any factory which is processing 20 tons a day, he need that much of energy. He need approximately 300 kilowatt. We need only 2,400 square meters, which I think every factory here who have that capacity have that much of roof area. This is also including all catwalk area, you know. So Kalbhavi solar project, they installed 300 kilowatt. It includes around 910 panels, and that reduced the electricity bill by 84%, and their monthly saving is approximately $35,000, and payback is around 3 years. So these are the real numbers which are coming from the processor actually who installed it. So this is their accounts department impact assessment report, which is signed by Mr. Kalbhavi, and he talked about how his electricity bill in May, June, and July dropped down because they started September, October, November, they start using electricity bill, and they find a big reduction in electricity bill, approximately 84%. So this is how it looks like. Simple, easy to manage, and that's it. If you really want to have more information, you can contact Fortel Solutions. They are bringing this information, and that's it. But it's something which is doable, which is easy to do, and we can go for it. Some processing plants already considering it in Nigeria. They are working on it, and I can give you a little bit of cost estimations. To install 300 kilowatt, I am talking about approximately $350,000. So it is not really much. Thank you very much. Okay, now I will invite the next speaker, Mr. Stefano Massari.
Good afternoon, everybody. Thank you for being here. I will present today a couple of topics which I think are of actual interest at the eve of the season of the crop. And one is dedicated to the post-harvest treatment of the RCN, and one is dedicated to the packaging of the same RCN and even of the kernel. So everybody are familiar with a situation like the one we see on the screen, like a huge amount of handling operation at the beginning of the crop for collecting and drying raw material, and with the situation of deterioration of the quality of the same when the raw material is not properly dried and treated, of course, with removal of the foreign matter coming from the field as well. So this is valid for both the exporter of the raw nut and the importer in the destination country and the processor. okay? Especially in time when the rainy season starts. Maybe not at the beginning of the crop. If you take the example of Ivory Coast, maybe at the beginning of the season there is not too much issue, but going through end of March, April, May, then we may have situation that we have seen. And the experience that many of us had in the past are really of this kind of situation. So we have introduced a solution for that, which is a mechanical post-harvest treatment, which allows to clean the raw nuts in high volume and in a short time, and dry to the proper moisture level required for the storage and for the shipment or for the transit to the destination market. Basically, you see here an example of installation, and we have come through that with a deep study of the behavior of the nut on the drying process. We have determined the various drying curves, and we have it is possible for us to understand and control completely the processing to bring the moisture between I mean, we have indicated here 18%, which is actually the moisture roughly that is immediately after the collection, and through the minimum level that would be 6%. Anyway, supposing to go from a raw material of 15-14% to an 8%, which would allow us to have a proper storage and a proper conservation of the product, you can see that basically we are on the tune of 200-250 minutes of drying. So that is basically what brought us to design this installation that actually guarantees that the curve is respected. So the advantages are, I think, almost obvious. The cleaning is basically removing the stones, the ground, the sand, the light foreign metals, the leaves, the rope, the stainless plastic, and the paper. Removes a good portion of empty nuts, which is allowing to increase the KOR, because the empty nut gets into the account of the KOR and it reduces it. And of course, drying the RCN to a level to a desired level in a controlled way, so we can control it. It's not that we over dry or we dry less. We want to get to 8%, we get to 8%, selling the packaging material and charge for the service. Here, other example, also for the kernels. Of course, this big bulk vacuum packing is valid for the kernel. You can imagine that now in Europe, there are, I would say, close to 30,000 tons of almond, hazelnuts, and other nuts packed in this way, going to the end users. Only cashew is not packed in big bag. Only cashew continues to be packed in 50 pounds bag, if not in 225. So there are the technologies there. We know everything. We can do the modified atmosphere as we want, and the costing here, especially for the kernel is on the tune of $50 per ton against the 60 of the traditional packaging. Okay, so there is a reduction here in Ivory Coast. I'm not, maybe in Vietnam or in India might be slightly different, but here, as all the packaging material are imported, the situation is like this. Also, the big bag, the vacuum big bag is imported, but nevertheless is becoming cheaper. So basically, these are the few concepts. I will run now a small video introducing the packaging in the big bulk bag generally for commodities and specifically for cashew. So the video can start. Thank you.
Thank you, Mr. Masari. Can you put the video on?
Billion tons a year. In times of climate change, food shortages, this is a major public concern. Sadly, a part of the food has already been lost or wasted in the supply chain during transport or storage. Many commodities are sensitive to moisture, oxidation, or insect infestation. But these issues can be easily prevented, even for organic products. We are VacuPack, and we protect dry commodities in non-toxic and organic way to maintain the quality of the product and to prevent losses. We use vacuum and mat technology, a way of packaging in which the packaging's internal atmosphere is changed. Vacuum decreases the volume of the internal atmosphere. Also, the vacuum is an important parameter when eliminating insect infestation. The VacuPack system, with a unique worldwide patented valve, controls the oxygen level by inserting nitrogen, carbon dioxide, or a mixture of these gases. We call it the three-weapon system, the combination of a controlled oxygen level, pressure, and temperature. Together with the use of CO2, it slows down the development of microorganisms. There is no unwanted moisture increase, nor moisture absorption or evaporation. It slows down the oxidation process. It eliminates insects in all stages. The VacuPack solution keeps your valuable commodities protected in a high-quality packaging material. With our MAP technique, the high quality of your commodities is secure. With less waste and easier and faster handling, the VacuPack method also gives you logistic benefits that save time and money. Our technique is a non-toxic, curative treatment of insect infestation. Your organic products stay organic, so that consumers can enjoy safe, healthy, and high-quality products.
Okay, the video can stop. Thank you.
Thank you, Mr. Masari. I would like to invite now Mr. Peter Masavi.
Good afternoon, ladies and gentlemen. I am going to have a very brief presentation on the opportunities for improving quality and the quantity of raw cashew nut production in West Africa. A little bit of an introduction. Cashew is increasingly becoming an important export crop in a number of countries. It is a leading foreign exchange earner to a number of growing countries in Africa. It is also a reliable source of income to poor resource farmers who, when the drought causes a crop failure. It is a sustainable tree crop to combat global warming because it is tolerant to drought and it is evergreen throughout the year. Actually, it deserves to have a carbon credit. It provides shade to livestock and it provides off-season feeds to livestock and poultry. On the other hand, it is a source of fuel and compost, and more importantly, it controls soil erosion. Constraints in cashew production, as we all know, low productivity. And the main reason is lack of improved planting materials, poor agronomic practices, including spacings, prunings, weedings, intercropping, disease, and insect pests. Another constraint is the poor quality of the raw cashew nuts. In most cases, we have small sizes which are not suitable to the current technologies. We have bad nut shapes, which are prevailing in many countries in Africa, where the selection of improved varieties have not been conducted. We also have diseased raw cashew nuts. We have also insect damage. We have some nuts which are void, and more importantly, the poor quality, the poor peeling of the tester. Sorry, the remote control has gone mad. Huh? Okay, can you go back? Go back again? Yes, now go in front. Next. Yes. What are the processing factory requirements in cashew industry? We need good nut shapes, which has a kidney shape, and we need low nut count, less than 180 per kilogram. Next. Next. The processing factories also, they require high holes recovery at the processing. And more importantly, there is a peeling of the tester to reduce the costs. Next. The market demand, all of us inside this room, we know. We need big kernels, white kernels, and holes. Next. How to address the issue of quality and quantity? First of all, we have to ensure that the cashew research program in each country is strengthened. If there is no research, cashew research program, there is no cashew industry in that country. It can collapse at any point in time. So we need to strengthen the breeding program and the crop protection program, not forgetting about the agronomy, vegetative propagation. We also have to put into consideration the aspect of human resource and the financial resources, including infrastructure. Networking is very important in order to exchange the knowledge and technologies, and also we need to strengthen the extension services. More importantly, we need to develop cost-effective marketing system and also support to cashew value chain. Next. African countries that have a lot of financial resources in cashew research is Tanzania, Mozambique, Cote d'Ivoire, Ghana, and of recent Zambia. Other countries which are moderately supporting cashew research program are Benin, Burkina Faso, Nigeria, Madagascar, Kenya, and others. Next. What needs to be done and by whom? Next. First of all, to provide the cashew research, support the cashew research program in terms of human and financial resources. How can this be done is through the introduction of the export levy, and the majority of that money should go back into supporting the industry, and research should be a beneficiary of it, extension services, and also the processing. Improve the infrastructure. Now, once that is done, then each country, they can undertake a local germplasm collection, identify the mother trees, characterize the mother trees, undertake studies on the genetic diversity to know if the materials collected within the country, they have a wider genetic base or narrow genetic base. If you have a wider genetic base, you don't need importation of the material. But if you have a narrow genetic base, you cannot avoid importing materials from other countries. Then from there, we can select improved planting material for multiplication and for the genetic trials. We can also establish science orchards for public and private estates. And at the end of the day, we'll establish nurseries, which can be public, private, or community nurseries. But here, we have to take a caution of the quality control. They have to be supervised by the cashew breeders. Next. This is a brief schematic program which I developed about 10 years ago. And the earliest you can develop a cashew variety is at minimum 9 to 10 years, not anything short of that one. Next. Multiplication of the improved planting material. Although vegetative propagation was successful in early 1990s, but in most countries it is not properly done in terms of the age of the grafting, and more importantly, the grafting materials. We know budding is successful, grafting is successful, tissue culture is on the progress, but training in grafting is necessary. Next. In terms of crop protection, West Africa, you don't need to bother much about the diseases. You only talk about diseases, but actually there are no diseases of economic importance in West Africa, but surely in East Africa, yes. But pests, like the sucking pests, are very important to be controlled. Next. The extension services, we need to undertake training on good agricultural practices, planting and transplanting. One would think that the cashew can be planted as a tree. It is not true. The mortality rates are very high until when the appropriate knowledge of transplanting is taking place. We need to have a care after planting. The seedlings need little bit of care. Grafted seedlings need more care. If you mix both of them, you will end up with the rootstock rather than the improved planting material. We hope also to take the care of the diseases and insect pests, harvesting, post-harvesting, handling, packaging, and the proper storage. Next. Processing and marketing. This is increasingly becoming an area of interest for the value chain actors in Africa, as you have seen from many who are making presentations. Government have been paying more attention to farmers, are forgetting completely about the processors. This is a chain. If you support only farmers without supporting the value addition, actually the chain cannot be completed. So it is high time now for African government to think between the lines and give maximum support to the processors as well. First of all, the processors will need probably to hold their stocks because the cost of holding stocks for processing is too high for small-scale processors who have little capital. So if we can create a fund that will be holding stocks for large and small-scale processors, we are going to increase the capacity of processing in Africa. Short of that one, we will be exporting more and more to Asian countries. Next. We also need to effectively utilize the cashew nuts, the kernels, the tester, and the shells. Next. With the kernels, we can make butter, we can make pasta, but of recent, cashew milkshake has become a hot cake in many markets in the world, including my country in Tanzania. Surprisingly, investors have not put a lot of effort on it. Next. The cash share value addition, it is slowly getting a momentum, but the value addition for the CNSL in Africa is not yet taking place. Next. Conclusion is that in order to improve quality and the quantity of raw cashew nuts in West Africa, governments need to pay attention to research and development to improve the quality, production to increase quality and quantity, value addition to involve producer organizations, marketing for the quality control. Thank you very much for your attention.
Thank you very much, Dr. Masari. Please, can you take your seat, please? Please. Thank you. Thank you very much. We will have more 10 minutes actually, and I will take only 2 questions, and then I would like to ask questions from the audience. Okay, we have some questions from there. Hello? Yeah.
This question is for Stephen. I heard that there is a lobby from Vinakas which is trying to stop the Burma kernel imports. What do you think about it?
Yeah. Right now is Vinakat is now trying to apply the tax for the Burma import or almost the kernel import. They are following Indian government to do that. But I don't think this will be success because what I said, Vietnam can benefit for import the Proma kernel to Vietnam. Vietnam benefit a lot. So I don't think if they apply, minimum it take 1 or 2 years. But it will not possible. I think so.
Thank you. Next question.
Yeah, I have two questions.
Sorry, I also have one thing to explain. Right now, in Vietnam, already have the import duty for kernel, even the Proma kernel. It's not zero before and now apply. Already have. But the Vietnam government support to import the kernel with the zero duty if you export to another country. It's not for local market. Yes. Thank you.
Thank you.
Yeah, a couple of questions. One is for Mr. Damodaran. You demonstrated, I mean, you mentioned about that case study of the plant in South India. Was it a small, medium, large? What was it?
It is a large plant,
Large plant.
150 tons per day,
Oh, okay.
approximately.
So, I mean, has anybody tried this with a small 20, 40, 50 ton capacity? Has been tried or not?
We have not made one, and I don't believe that there is one. But the technology was actually, the limitation in technology was also coming from the turbine world.
Right.
And of late, in the last few years, there are turbine manufacturers that have become more and more economically viable
Right.
in the small capacity, even in 300 kilowatts. If you want to have a power plant, you can have it today. And we have partners that offer that solution.
Right now, compared to, say, 150 ton plant and, say, 30, 40 ton plant, what would be the per kilowatt hour investment? Would it be widely different or only slightly different?
No, it is still not. Approximately, it is 1 million kilowatts. $1 million per megawatt of power generation.
Right.
In the higher capacity range. In the lower capacity range, it goes to 1.4, maybe 1.8 in the really low capacity range.
So almost 50 to 70% more for the smaller capacity.
That is correct. But these are very rough cut numbers.
Rough cut. Okay, all right. Thank you. Thank you. And a question for Stefano. Traditionally, we have all been under the impression that for proper drying of the raw cashew, you need extended drying over 8 to 10 hours of sun drying. Now, your system is talking of doing it much faster. So will the accelerated drying affect the quality of the kernel inside?
According to our trials, no. There is no difference in the quality that we find in the natural drying and in the mechanical drying, if we can call it like that. For a simple reason, the mechanical drying is completely controlled.
Right.
So we can control the temperature. Then if you put a nut in the sun, you don't control the temperature. You can go at 80 degrees because the tarmac behind that reflect the heat on the kernel. So you very often see some drop of CNSL coming out of the and stain the surface of the floor.
Right.
In the mechanical system, we do not have that effect for the simple reason that we give always the same kind of heat to the nut, and it is a heat that is not affecting that one. Another aspect is that we target mainly the shell. Okay, so we remove the moisture from the shell superficially, and then the nuts get into equilibrium, transferring the moisture of the kernel to the shell in a longer time.
Right.
So that is
now I forgot. I don't know whether you mentioned it in your presentation. But how long does it take? I mean, how long is the cycle? How long does it take?
Look, to go from 14-15% to 8 is about 250 minutes. So 4 hours.
And what is the capacity of the machine? How many?
That system you saw in the presentation is 100 ton a day. Of
100
course,
ton.
it can be multiplied on whatever reason,
Right.
whatever
And
capacity.
and the last question: have you tried this machine already, or you are still in the?
Yeah, no, we are installing a system now in Grand Bassam here in Abidjan. It's
that
under
will-
installation now.
So this will be the first season. This will be the first season.
Hopefully we get before the rains. we will get it ready. Yes.
Thank you. Thank you.
Yes.
Thank you very much. There is one here and one there. And I think we will take more 3 questions and that's it. One there.
Yeah, good evening. This question is for Dr. Peter Mesave. There is a presentation where the DOC can convert it into fertilizer. Is it vermicompost or biofertilizer? If it is vermicompost, can it take the worms? Can they take 3% of CNSL?
Yeah, actually, what is happening is my colleague in Mozambique has been undertaking that study, and he has come up with the finalization that it is possible not removing even the CNSL. You can even remove the CNSL if you want. Both ways are applicable, and it has been working effectively. The only problem is that it takes a little bit of time, and also the available materials are not readily available for that.
Thank you.
Can you pass the mic? Here. Okay, one more there. That's it. And then here.
Bonsoir, Smora Blay, coordinateur Finakasi. J'ai une question concernant le système solaire. La démonstration, l'exposé a démontré qu'avec un système solaire sur les toits, ça permet de réduire considérablement l'énergie utilisée. Et nous savons qu'en Côte d'Ivoire, ici, bon, généralement en Afrique, le coût de l'électricité est un facteur bloquant en ce qui concerne la transformation. J'aimerais savoir si le système de production solaire qui a été installé en Inde, si c'est en phase d'exportation. C'est-à-dire que si on peut exporter actuellement pour que on puisse intégrer ça dans le prochain projet d'industrialisation de la noix de cajou en Afrique. Merci.
So, ça c'est pour this is for the solar energy, isn't it? I didn't get completely your question, but I think you all would like to see what is the difference between India and here. Is there some other complications here? There's no translators here.
He asked if the technology of solar energy is available, if it can be transferred from India to Côte d'Ivoire.
In terms of the capex, it's not much difference. In Africa, we have high import duties, then installation cost is higher. That's the difference. And in terms of only one thing which can be different in West Africa is the time of Harmattan. Time of Harmattan, a lot of dust in the air, and so installation here will be a bit different. You have to make sure that your panels are clean during that time. So maybe technically there can be a little difference, but if you see on the cost-wise, not much. You will not see big difference here. The last question.
Bonsoir. Je suis Philippe Cour de l'Ivoire de Noix de Cajou, responsable export. Ma question concerne les backpacks. J'ai vu un peu votre présentation, je vois que c'est une bonne technologie en termes d'espace dans les conteneurs, que ce soit les conteneurs de 20 pieds, de 40 pieds. Et donc ma question est la suivante. Quel est le temps de conservation? Puisque généralement, lorsqu'on envoie le navire, on fait soit 19 à 20 jours selon la destination, ou même 3 mois, 6 mois par moment. Donc j'aimerais connaître un peu le temps de conservation. Ça, c'est la première question. Maintenant, la deuxième concerne le transfert de technologie en Côte d'Ivoire.
I have not got the first one. Anyway,
Okay.
the last two is this. So the the lifetime is pretty similar to a packaging of 50 pounds. I mean, there is no basically difference if the modified atmosphere inside the package is done properly. So it is many, many months, even years. You can stock the product really in a long time because you have no oxygen, you have nitrogen, you have which is preventing the process of rancidity, and you have the CO2 that prevents the development of insect, together with the low oxygen level. So this is giving a pretty high lifetime of the package. The technology to Ivory Coast, we are committed to transfer it here. As I said, we would be even in a position shortly to make it as a service. So, for example, suppose you don't have you don't have the need to pack the entire production, or you have, say, 1 container per month, 2 containers per month, or something like that. We can provide you the service of packaging that container at the moment you are ready to ship it to your customer. So you can go to your customer offering that kind of packaging. Probably not all the customer will take it and will accept it, but some of them may do. So you can have that kind of service from us shortly. We are not yet in place, but we will be shortly, and we can give you that as a service. So you buy the packaging material, you pay the service for us coming to your factory and making the packaging properly, as it has to be done. So la première question.
Non, je disais, je parlais du temps de conservation en fait.
Le temps de conservation.
Yes.
Mois ou jusqu'à 1 an et demi, pas de problème.
Et la validation?
Et là?
Validation?
Je n'ai pas compris.
Je demande s'il y a une étude de validation en fait.
Is validated? Oui. Yes, we are already packaging nuts for example, for Lidl.
Donc, si je me permets, vous dites 1 an, 1 an et demi. Allô? Vous m'écoutez? Je disais, si je me permets, vous dites 1 an, 1 an et demi. Pour la conservation en fait de vos vac-pack.
Oui. Il y a un shelf life très enlongé parce que vous avez les conditions à l'intérieur de la confection qui sont faites pour ça. Donc, personne il tiendra un big bag de cajou 1 an et demi. Personne. Donc, je pense que votre client, cette typologie d'emballage est faite pour le just-in-time, pour le batch ready. OK? Votre réservoir, il va aller utiliser dans la ligne de production de roasting immédiatement.
En fait, moi, j'ai une petite préoccupation. Je ne suis pas tout à fait satisfait.
Excuse me, can we take this because it's getting very personal? We can, like Mr. Masari is there, we can take it later. Okay, and he's going to be here the next 3-4 days, so you can talk to him. Okay, thank you very much. Give my panel a big applaud. I think these people did a very good job and share a lot of knowledge. I think we end the session here. Thank you very much.
Merci beaucoup, mesdames et messieurs. Je vous prie de faire des ovations. Est-ce qu'on peut baisser le son à la régie, s'il vous plaît? Je vous prie de faire des ovations pour monsieur Shakti Pal, qui a donc modéré cette session concernant les nouvelles technologies apportées au domaine du cajou. Et il va donc remettre à chacun de ces speakers ces mementos. Le premier va à l'endroit de monsieur Santar Damodan. Voilà. Sous vos ovations, s'il vous plaît, mesdames et messieurs. Vos chaleureuses ovations et encouragements. Et le deuxième pour monsieur Stefano Massari. Alors, Monsieur Peter Massawe. Et enfin, le dernier à Monsieur Van Thuen. Monsieur Stéphane était avec nous ce matin, il a reçu un memento. Voilà. Donc, merci déjà pour votre collaboration. Alors, pour remettre le memento du modérateur, mesdames et messieurs, vous allez rester là. Pour remettre, pour remettre le memento du modérateur, je vais inviter ici le docteur Ulrich Sabel-Kochela. Le docteur Ulrich Sabel-Kochela qui va nous rejoindre. Dr. Ulrich Sabel, so please join us to give the memento of the moderator. Voilà, with your warm applause, please, to receive Dr. Ulrich Sabel-Kochela. Thank you. Please remain there. Remain there for the photo. Je vous prie de rester pour la photo de fin, merci. Merci beaucoup. Ok. And, merci beaucoup. Et ensemble, messieurs, tous les 6 vont faire la photo de famille. You remain there, doctor, please. Remain there for everyone for the photo in the middle. Okay, thanks.